I welcome you all to this FDP. Today we have with us Mr.K.Viswanath Reddy, CPU Performance Architect, Intel Bengaluru. Mr.K.Viswanath Reddy is an experienced creative engineer, good team player and analyst, and architect for hardware and software systems. He holds a master degree in tech specialized in VLSI and embedded systems. With a strong track record of computer architecture knowledge, along with advanced programming skills ranging from C to Python, analyzing performance of cutting-edge processors, developing new methodologies in finding critical bugs within a short span of time. He is experienced in working with various multinational teams across the globe, which includes from requirements gathering to CPU architects, RTL designers, verification, back-end validation till marketing of the product. Currently, he is working on core internal performance validation on leading-edge big course at Intel Corporation, Bengaluru. His specialties include performance analysis, architecture analysis, problem solving, customer-oriented system specification, good decision-making skills, advanced programming skills, AI, ML, etc. We are happy to have you here, sir, for this morning session. I kindly request Dr. Y. Neeraja, head of the department, to welcome sir with a floor call. Please, sir. Thank you, ma'am. Thank you, sir. I now kindly request our resource person to take over the session. Please, sir. Hello. Am I audible? Yes.
for a beautiful intro, and thanks for inviting me to this tech talk. Good morning, all. Hope your first session was wonderful. You have a lot of things to learn from this presentation. So let's get started. So first of all, I wanted to admit all of these slide sets are not mine. So I have taken a lot of content from the different architects and technologies across Intel and academia. And I would like to especially thank my cousin brother, who is my Vasu, who did the first session for this program. He is my cousin brother. So and then I would like to extend my thanks to my managers, Giridhar and Shekhar, and principal engineers Ajit and Kartik, who though they are not here, but they have contributed to this presentation in reviewing and filtering the sensitive data. And then of course, to our Shakti Shanmugam sir. So I think Sir already gave the intro of mine. So I just wanted to put here. So I did my all my schooling and everything from It's clear, right? Okay. So I did all my schooling and everything from my hometown, that is Pradujur, Andhra Pradesh. And then later we moved. So I gave gate and then I secured a seat in Army College of Engineering. And then I got VLSI and Embedded Systems post graduation. That's my alma mater. And then later I was able to secure internship at Intel during the campus placement. So during the internship, I was part of the back end. So during the back end, I was doing like the placement and route, starting from clock synthesis, and then RC analysis, layout, and all of this stuff. But somehow I was not liking that particular division. So I was posted into the atom division. That atom division was, say, low power division to compete the ARM processors. By then, the ARM processors were dominating all mobile chipsets. For example, if you take all the laptops will be having the x86 architecture. That is from Intel. And x86 architecture is not only on Intel CPUs, but it is a basis for AMD CPUs as well. So now, whenever you see a laptop with Intel core inside or the Ryzen is a brand from AMD. So all of these are from x86 architecture. So most of the laptops are powered with x86 architecture. So Intel is dominating the laptop division. But while coming to the mobile division, it was not that competitive compared to the ARM processors. Why was that? It's because the inherent architecture of x86 is a CISC architecture. It is complex instruction set architecture. So what is it? And ARM adopts the CISC architecture, which is a reduced instruction set architecture. The difference between the CISC architecture and the RISC architecture is, in this CISC architecture, one instruction will be broken down into multiple micro-ops. These micro-ops will be executed by the CPU. But whereas in the RISC architecture, these micro-ops each micro-op will be considered as a one instruction. So that is the reason why that architecture is very good at low power, but it won't beat the performance. So when we come to the performance, I will be showing the 6 vectors how we can improve the system performance. During that slide, we can cover that. So later I moved to the later I got the permanent position with ARM. So I was doing the system level performance analysis. CPU at the center, we will be doing, there will be a CPU and there will be interconnect and the memory controller. So we will be stressing the CPU, we will be running all the benchmarks oriented toward the CPU, and we will be analyzing the latency and bandwidth of the entire system. So later, for some reason, when I was doing system performance analysis, the CPU and the memory controller, everything was black box to us. So for some reason, it was I was so enthusiastic to learn the core internals. So that is where I developed a passion towards the CPU performance. So that is where I got the opportunity from Intel in 2018. So I joined the CPU application team. I was one of the first recruits when this particular core performance team developed in Intel. Even that was the first team in entire India. So prior to that, there was no core performance team in India. Not only at Intel, across India. The reason being why they delegated the core performance from, it was being done at Israel. Why it was moved from Israel to India? Because during that time they were at war. So they were short of resources. So and then moreover, the performance was being done by the modeling people. So they wanted to bifurcate the performance and the modeling. So you know about the modeling, right? We will get to know to that terminology very soon. So later, our team started merged with the architects team. So now we are doing the enhancements on top of the architecture. So I am very passionate about playing sports. Like last 2 weeks back, there was a volleyball tournament championship. We won it. We were the winners of it. And here is my second level manager, with whom I was receiving the award. This was my volleyball team, and this is my PMP team, that is core performance team, and this is the adjacent teams like the verification team, quality grading team, post silicon teams, and all of that. So now let us do some small activity. Maybe this activity you can play with your students to get their attention. So let's assume this is you. So what is today? Right. What is today? 21st June, but what is the day? From Saturday. What is this? What is the day? Saturday. It's the simple math. From here to -7. What is this day? Okay. So quickly I am going to explain to you how can you, whenever a date is given, within next 2 minutes, you will be able to learn. Whenever a date is given, you will be able to guess the date, determine a date. So you need to learn few codes. Like the first one is January. January is a first month, so the code is 1. Second, February. So what comes into your mind when I say February? It's February 14th, right? So 1 we have given to January. So we have 4. The February code is 4. So March. So March 1st. We do March 1st with 2 hands and 2 legs. So that is March code is 4. So April. April, Fool. So Fool will have always 0. Okay. May. May means goat. Meka. So in Telugu, Meka. So May. Meka. 2 words. Okay. May code is 2. So June. June means whenever the school will reopen and the children have to use their all full 5 senses to get into the school mode. So June is 5. July. So July means July person will have always 0 marks. So August. So when I say August, what comes to your mind? August 15. Yes. But on August 15, what do you? Which flag do you host? It's tricolor flag. So code is 3. So September. It's a very big one. So since it is a very big, so it will be like 6. The September code is 6. October. When I say October, which comes to your mind? October 2nd, Gandhiji. So Gandhiji is our father of the nation. Always father secures a first rank within the family. So October code is first. November. In November, when I say November, which comes to your mind? Children's Day. Exactly. So that is 14. So one we have already given to October. The remaining is 4. And there is a connection between February to November. What is that?
9 months.
It's exactly 9 months. Got it. So it's exactly 9 months. And then December. It's a very big, so it is also takes code of 6. Now I hope you remember all the codes. So randomly let's test. What is code of P? Okay. So let's see. What is code for July? Okay. So what is code for November? 4. Because it's 14, we have given 1, there is 4. And what is code for May? 2. I intentionally call out in Telugu because you people will understand. Okay. So, let's break this puzzle. 14 plus what is the code? 4. 14 plus 4? 18. 2025 pixel code is 2. 14 plus 4 plus 2. 20. 20 divided by 7. Why we need to do divided by 7? Because there are 7 days in a week. Exactly. So what is the remainder? 6. So Sunday is 1. Monday, Tuesday, Wednesday, Thursday, Friday. Friday is 6. So the code is remainder is 6. So it's Friday. Okay? Yeah, you can implement this to get attention from your students as well. Okay, so we got one activity. So I hope it helped you to learn something. Okay, so let's see. You might have heard like a lot of things: architecture, micro-architecture. What are these jargons? First of all, before coming to this session, I was talking to our principal sir, Ravi, and he was telling me we need a lot of motivation to drive people towards semiconductor fields. So, with that basis, I would like to put some light on the architecture and microarchitecture. When I say architecture, x86, I was keep calling x86. What is x86? Why they name x86? Because they first started with one microcontroller, so microprocessor, and then they named it x86. So since then it is being called as x86 architecture for all the Intel processors. And whenever we change the instruction set, why do we need to change the instruction set first of all? What is the necessity to change the instruction set? What is the instruction? For example, move A comma B. So we are moving one value to the another value. So similarly, that is a very simplified instruction. But if you take what exactly the move does, the move has to fetch the data from the memory. That is, it has to load the memory, and then it has to put into the some other address. That is, it has to store. So it does this. This is a very complex instruction. So, but in the growing space of the AML, So they wanted to do a lot of matrix multiplications. Why we need to do a lot of matrix multiplication? For example, if you are taking face recognition, how the Facebook and all of these social media type apps are doing, how they are doing. So whenever you open your phone, right, it will show, please tag, who is this? It will show one, it will pop up one name, one photo. So you, as soon as you put the name to the system, it will filter all the photos related to that person. How it is doing internally with that short span of time. It is a AM. How it is doing? It requires a lot of computations to be performed in the at the hardware level. So to do a lot of computations, we have to modify the architecture. How we need to modify the architecture? We have to bring a lot of complex instructions. Like instead of doing a move, do some operation, and then one more operation. Like first fetch the data, do matrix multiplication, lot matrix multiplication, and then store the data. So for that they have introduced like something like TMUL, that is tile matrix multiplication operations. So such instruction architecture will come first. So what is microarchitecture? Microarchitecture is nothing but the base will be the architecture. On top of that, how you are building your routing. For example, the cache sizes and the pipelines. How you are designing the pipelines. All of these and buffer sizes, which buffers you are using, and how many ALU units, how many FMA units, fuse, multiply instructions. Am I boring? Am I boring? Am I too fast? Please let me know. So I will be going in that mode. So the main intent of this presentation is at least to view something from this presentation at the end of the day. So processors with different architectures can support the same architecture. So you can take the base same, just like a pizza. You will take the base same and they will add some different top-ups, it becomes a different pizza. Okay? So it's very similar to that. What is the compatibility? Compatibility is nothing but designing a software, the architecture should be able to support any, even if you, for example, if you are buying a phone, and if it is after 1 year of usage, and if you wanted to download one of the interesting applications, and then it says, no, your hardware is not supporting, please install, please upgrade your software. It won't say hardware won't support. Please install the higher grade of OS. But your OS will not get upgraded. It says, no, because my hardware is limited. So you should not have such issues when you go with the Intel processors, usually. So Intel will support usually like at least 10 years of backward compatibility. So there are 6 vectors to improve the system level performance. Let's take, for example, your laptop. How can we improve your laptop performance? So the first thing is architecture. We have seen how the TMUL. Second one is the microarchitecture. If you put a lot of ALU units, so it will do a lot of computations, and then your instruction, instead of executing in 10 cycles, it will execute in 1 cycle or 2 cycles. So it will save a lot of time. What is the process technology? Process technology is like you might have heard like 10 nanometer, 2 nanometer, and all of these, right? So that will vary because inside the transistor you are making. So previously, just assume in the magnified lens, the transistor was this much when it was at 5 nanometer. When you move to the 2 nanometer, it becomes this much. So if it is becoming from this much to this much, you can put a lot of transistors, which means you can put a lot of computational logics. So you can support more of the features. Since you see, for example, you have a phone, right? Phone will be this much size. You cannot increase the phone this much by keeping all the features. So it should be this much only, but we should be able to increase its performance. How can we increase? By changing the size of the transistor. And compiler. For example, you are doing some change in the architecture, but if you are not upgrading your compiler software, what it happens? So somebody will write an end application. For example, if I am developing one app, I will develop one app in Android Studio. Okay. So if that app is not taking the updated compiler, the compiler which does not know the updated instructions, it knows only the n-1 architecture instruction, then what happens? Then you won't be able to capture the updated version of the architecture. So you need to have the compiler updation system. Similarly, the software optimizations. Besides the compiler optimizations, you also need the software optimizations. For example, you might be writing one Python code, but your laptop or anything will be powered with 32 or 64 cores. So if it is powered with that many cores, if you are running only one small plain Python program, then it will run only on one CPU. But I want to take advantage of the whole system. How can I take? You can use the thread executor or the multiprocessing, multi-threading. So all of these built-in software routines, you can use them to spawn different threads and then execute your application very fast. So coming to the system design, apart from the CPU, so most of these are related to CPU, the other one is system design. So the CPU, though it is a hard to drain on the system, but it will be connected with the memory, with all the other I/O peripherals, right? So all of these also needs to be built up so that it will give the desired CPU performance, right? Hope everybody is following it. Okay, in the interest of time, I wanted to do it. How a code is formed? The code will be formed how a next gen code will be formed. So, for example, which compiler you know? Generally GCC, ICC. ICC is a Intel's proprietary compiler, but GCC is a well-known compiler, which compiles the C. Whenever you write a C program, you compile, you use GCC minus this program, and it will give the binary format. So, if that GCC version is not updated with the instruction what we developed in the architecture, then it won't recognize. See, it will consume the application, the end application, and it knows only the n-1 architecture instructions, but it does not know the latest instruction addition. So what happens if that does not know? Then it won't try to fit into the disassembly. What is assembly language? Right? So generally the compiler will give the output of the assembly language. The assembly language, you can see which instructions. Those are the main instructions. Okay. It has to get updated. All of these to be updated so that we will get the next gen performance. The short overview on a new core combination. Generally, a new core, new CPU, how they will come up with a new CPU. So there will be a project manager. The project manager will have a clear understanding that I have to get my competitor is doing like 10, almost 20x improvement in the next gen. So I have to do 30x, 30%. So how can I do that? So first he will put like performance is 30%, power, how much power it can dissipate. For example, you might be taking a laptop and then it has to last at least 5 to 6 hours, right? Otherwise you won't buy the laptop. End user PPA targets, we call the PPA targets. Power, performance, or area. The area is nothing but again, as I was telling, if we string the transistor, we can put a lot of transistors within the same area. So these PPA matrix we will have, and later once we have a matrix, so there will be a feature finalization meetings. So usually the architects will have a bird's eye, like they will be having all the information starting from the n-1 core bugs. Usually they focus on the bugs, how can they improve the bugs, and then they might have seen some improvements, but due to last minute accommodations, timing issues, or STA, static timing analysis, hold time analysis, they could not accommodate the feature in the n-1 the CPU, n-1 CPU. So they wanted to accommodate in the current CPU. That is second thing. And the third one, they will be taking, internal research teams. So they will be feeding the data, and there will be another team which will be focusing on the competitive architecture, how they are doing, what we are lagging. So all of these information will be with the, and most importantly, academia. So all the research papers, so colleges, industries will be collaborating with lot of institutions, and then they will be getting the information from there as well. So once we have architects have a bird's eye view, so they will be coming up with a proposal on the particular feature. They will code the feature in the C++ language, and they will come up. This is the performance. It is going to give like 0.5% out of the 30% of performance, and this much of power it is going to consume, this much of area. All the PPA targets, and then whether is this the right time or not. All of these things will get decided within the feature finalization meetings. So where the architects, designers, and modeling, all the performance teams will be. So they will debate on the feature whether this should go now or not. If it is already in the competitive architecture, definitely we have to publish, no matter what. But if it is a new one, then we will. So once the feature is on, there will be a spec document. Once the feature is ready, the project manager will give go green signal. So the designers will have the spec document, and they will forward it in the RTL. Once it is coded in the RTL will be uploaded into one of the revisions. That is, take repository or subversion kind of revision. From there, it will be consumed. Those models will be consumed by the verification teams, performance teams, and the backend teams. Okay, that is where the front end and backend bifurcation happens. So front end. So since I am from the front end, I am going to cover mostly on the front end side. So everybody receives model at the same time. So once we receive the model, we will set up. We will start running our standard benchmark. How do we get the standard benchmark? These benchmarks there will be some consortiums, like notably spec consortiums. Spec consortium and Hallmark, language, all of these. Now I would like to give some influence in the code. Are you interested in this, or we'll move to the next one? So we have branch prediction units. If it is too much, then I think I will skip it. Anybody interested, or will skip it? So it's you will skip this one. Okay. Why the AAML now? Can you please tell me why AAML now? I know robotics been there for a long time in Japan, since 1950s. Why we are talking about now? What is the necessity? Sorry? Huh? Yeah, so more applications, more speed is required. Let's see. First thing is the hardware support. Back then, our hardware was not supporting that much. Though our hardware supports, we need to keep a lot of such hardwares stacked together in rooms, big rooms, to achieve very minimalistic performance. And the training cost will explode like that. The same training of GPT-3 in 2020 cost was $12 million. Now, within 5 years, it became $1 million. That is the viability. So, all the companies generally, why do they invest? They have to get something in return, right? So, everything in the end is a money, it's a trade in money. So, now coming to the CPU, GPU, so now we have a lot of NVIDIA A800, H100 chips. And then CPU, latest Xeon from Intel. And even the cloud computing, right? AWS, you might have heard about AWS, Amazon AWS, Google Cloud. They will be providing the server headless systems where you can subscribe and then use them. And then more of like the edge area. For example, this is a smartwatch. So most of the computations will be done at the edge computing. Okay. Now most of the data will be here, and then it will be again supplied to the servers. Data explosion. There is a lot of data now being generated. How this data is being generated? If you go to a more supermarket or any nearby supermarket, they will be using computers. Back then there were no computers, right? Now because of that, a lot of data is being generated. Not only that, so all of in our home, everything became a smart device. Like fan smart, and then watch smart, goggles smart, TV smart, everything is smart. Because of that, a lot of data is being generated. How do we analyze that huge data, humongous data? Very difficult, right? If you see, there is one stat circulating a lot. 90% of world's data created in past 2 years. You can imagine that. It's like we are generating 2.5 as a globe. We are generating 2.3 billion bytes daily. That is 10 to the power of 18. 3 billion is 10 to the power of 18 bytes of data. So with that huge data, if you want to analyze, it's not easy. Just analyzing and then making sense of that particular data. Algorithmic breakthroughs. Back then, there were no very good sophisticated algorithms. Like in 2012, we had like deep learning with natural language processing. For example, if you wanted to trade, in the end everything is a trade and money, right? So if you wanted to trade with one country, let's say some Japan, a French country, a German country. So you wanted to speak your language, but back then they were talking in English, or the other person also will be talking their own language. There will be like mediators, and this person will say something to the mediator. They will convert and they will add some masala or something. They will convert to another mediator. So a lot of filtering was used to happen. But now the real time, as you speak in your language, that gets converted to the opposite person language, and it will be delivered to the person directly. How is that? You can track the deal very appropriately, right? So there won't be any like intermediate, and you can directly talk. I want this one and I want this one. You can tell the specifications also. I want this one, and the deal we can close within very few minutes. If the deal is not getting back, then we get back out. So that is the natural language processing. And 2017, we got a very sophisticated technology that is the transformers. That is GPT. You might have heard about ChatGPT, right? How many of you are using ChatGPT? Super. So, GPT is based on the GPT technology. GPT is, may you know what is the abbreviation of GPT? Generative Pre-trained Transformer. So, since then we got all the large language models. So later in 2022 we got the diffusion model. So what is a diffusion model? Like in 2017 we will give one phrase and then it used to generate a summary format in the form of text. But now these thanks to the diffusion models, because of the diffusion models, we are able to train with the images. The training happens text to image. So whenever you give text, the image comes out. So I want this one, so it will generate. So I'm going to show the Gamma A. How many of you use Gamma A? Gamma A is a very sophisticated tool to generate the PowerPoint presentations. You can just give one phrase. I just, for example, what is CPU architecture? The Gamma A. And you need to specify how many slides you want, like 8, 16 or so. It will generate full-fledged presentation within 1 or 2 minutes. How about that? Based on that, you can take that as a basis and then you can present to your students. Now it's very cheap and easy. So how it became very cheap? Because there are open source models coming from Meta, Llama. So why there is that Meta very bad to use open source? Any idea why companies usually do open source? In the end, every company they have established to get some revenue, right? Why they want to give open? Exactly. So it's very similar to like the Geo. Exactly.
After that, they want to pay.
Exactly. See, if you give the sophisticated technology, open source, they won't give the full. They will give the open source, but on top of that, there will be a. If you want something, then there will be a premium. Again, you have to pay. So they are asking people please use it so that people will get accustomed with that particular technology and then they can do. Very similar in any company. Though tomorrow you upload, we also do the same thing. That's how the business works. So there are like other jargon words you might keep hearing, and then if not, you might keep here soon in the future. Those are like artificial intelligence, machine learning, deep learning, data science, data analytics. If anybody knows, then you please tell me. Drop silence. Yes, so, artificial intelligence, you can think like a human being. It's a complete human being with artificial intelligence instead of the human intelligence. Like the end product will be like self-driving cars. Machine learning. Machine learning is a subset of artificial intelligence, and it will be having like it will be using all the statistical tools, all the mathematical tools. Like it is divided into again 3 subplots. Supervised machine learning. We will give the predicted like cat. We will give cat image and you will label this is a cat. While training, while inferring, you just give the image. It will infer it is a cat. That is the supervised learning. Unsupervised machine learning. Like here, you won't give any objects. You will use like K means clustering. For example, you will go to the supermarket. You will buy all the vegetables and all the fruits. You will put everything in one basket. And once you go home, you will put everything on the floor, and you want it to separate, right? That separation is nothing but K means of that. So you will separate tomatoes, aloo, and everything. Right? That is called the K means of that. That is the unsupervised machine learning. Coming to the reinforcement, like it's a blend of supervised and unsupervised. Again, deep learning. Deep learning again divided into the three things. This is when you see the deep learning, it's like artificial ANN, artificial neural networks. It deals mainly with the data. Like we have seen the GPT technology, transformer, how it is used. That's it. CNN, convolution neural network. This is mainly for the image processing. And the recurrent neural network. This is mainly for the time series data, like real time inside the aeroplanes. Inside, while doing the operation, it has to go to the precise. Or most recently, the drone attacks. We want the precise. When you feed the coordinates, it has to go and hit the terrorist locations at the precise point. Right? How we are doing? This is the real time. So they were using the deep learning. So data science. Data science is a combination of all of these. It's like analyzing the data and making sense out of it. This is data science. So this is it's not very clear here, but this is a deep learning neural network, and this is a machine learning artificial intelligence. How the large language models started from RNNs to transformers. Back then, what are pre-2017 talking about? What are recurrent neural networks? So all of you might be familiar with the Google Gmail, right? So while using Google Gmail, I think during 2015, 2016 time frame, even now today, so when you type something, you like the suggestions. Those suggestions were being generated from recurrent neural networks. And the recurrent neural network had some issue, the forgettable issue. So when it was, I will come to that slide. So like those market price, the transformer revolution came in 2017 with the Google Brain. When the Google Brain was published, the attention is all you need. That is a paper published by the Google Brain. With this, the GPT architecture enhanced very fast. It executed the sequential process. The RNN and LSTM technologies, they were processing very sequential. For example, when you are reading a book, the lecture is going in the seminar hall. It is going to was taking each word and it was processing. But here, attention is all you need. Attention is nothing but focus. We don't need even in our human brain to process seminar, lecture, seminar. That's it, right? Seminar hall. That's it all we want. We don't want the all of this, right? So that is what the attention. Because of that, the natural language processing became very fast. How the transformers change this thing, mainly the focus. Not very clear here. Is it very clear? Okay. The cat, sat, and the man, which I was giving, right? So it has to associate. It has to just focus on cat, sat, man. It can omit like three other words. But in the previous technologies, it used to take each in the sequential manner. Now, in the transformers, take everything with the weightages. parallel instead of making the sequential. Why it is a big deal? It's a parallel processing, how our brain works. Accuracy is better at understanding contextual. It's not so precise, but sometimes it can make some issue. But going forward, that gets. But we are giving at the end. See, always there is one saying, right? Something is better than nothing. They started with something. Later, the OpenAI, they started rolling out the ChatGPT. For the first ChatGPT, nobody cared because it was very damn slow. For the second ChatGPT, it attracted few other customers. Third version of the GPT, gone. I think it was the fastest app ever downloaded from the App Store or Play Store. Real world analysis, like it's like book reading, whatever. So in the old days, like reading one by one, but like through the transformers, you can like skimming and scanning the entire book. So the GPT-1. So these are the GPT technologies. This one is flash. We can click on the parameters. 117 million parameters. What are these parameters? While training, right? We have seen the cat, sand, and the man. How many words are there? 6 words. Those are the parameters. Okay. This GPT-1 was trained with 117 million parameters. Estimated training cost $30,000 to $50,000. Estimated training time 1 month based on the low-end GPUs. 2019, just 1 year after, these parameters include from million to the billion. Even the training cost more or less similar, but they have taken some more time with advanced GPUs. Like you need to understand how many parameters are getting multiplied and what kind of GPUs are being used. Same, $175 billion. So 75 billion parameters. 2023, it went all the way 1.7 trillion parameters. It's like they have included everything. Whatever present in the world, they want to do it. There's still some more GPT technologies, but they are not published openly. Where do we use AI? We didn't talk about AI. So we have seen some things. Maybe I wanted to hear from all of you. Maybe any doubts also. Yeah, it became a necessity. How about from here? I keep hearing only from here. Where do we use AI? Day to day, where do we use AI in sharp marks? Really? Okay. How do they use? It's okay. So, like, exactly whatever you said is true. How they are going to use? They are going to take all the customer, we buy something, right? They will take the data. Next time when you want to buy, so for example, you might have gone to that particular shop on Wednesday. Next Wednesday, you will get some message from the shop. So you bought this one last time. Now it increased by 2 rupees. Please go. So how? It's not some human is not monitoring it. It's all AI data analytics. And then drone strikes, precision drone strikes, and then natural language processing, and image recognition. All of these are happening. And the slides, everyday life, like Hey Siri, Hey Google, all of these are AI. Or the social media content, recommendations, right? Whenever you are watching some episode on Netflix, you will start recommending the similar episodes, or for that matter, even on YouTube. You will watch one video, and then the similar videos will be appearing on your right side, right? How it is doing? All these are processing, business productivity, and so yeah, I wanted to. So this will be more important for you, like Grammarly. So being a day on I use Grammarly. I was very poor at English grammar. At least I'm now able to communicate clearly because of some tools. One of them is the Grammarly. Grammarly you can install on your laptops. It will suggest the cleaner way, the grammatical. It will pinpoint the grammatical mistakes in your while writing an email or while preparing slide decks. It will be helpful. So you need to be very good at the communication so that your students will learn from you. So healthcare. So healthcare, how Zoom in. So once you know the Google Zoom, right? So when you have the Zoom meeting, you don't need to take the notes. Once the meeting is done, it will generate the meeting minutes automatically, and then it will generate the ARs also automatically. That is the Zoom meeting, and they are still rolling out a lot more interesting features over there. And finance, like even in the healthcare, right? Like for example, it will collect a lot of data from now. Once you go to the hospital, there will be a lot of from all different divisions will be there. You will go to each division, and every information will be fed under with one tag. AI will analyze quickly what is happening, and then it will say, "Friend, this is the basic diagnosis information." Right? So that finance, fraud, while you fraud, whether it is a fraud or not. Entertainment. So like transport, education, climate. So everywhere we use AI. Going forward, it became like we can't even differentiate AI with the human. It is going to be to that level. But we should not fear. We should always embrace the technology. We should, that is, applaud the technology. We should always leverage the technology, whatever existing, and then get best out of it. So, we talked about the interesting applications of the AI. Now let's discuss what is the necessity to have security in AI. First one is the hardware vulnerabilities. So here I want to pause and I want to take some questions. From back side, any questions please? Okay. So let's continue. So why do we need security in AI-enabled systems? There will be like a hardware vulnerabilities, side channel attacks. Do we have a code here? So side channel attacks, for example, if you are accessing something to your cache, right? While accessing, there will be some electromagnetic discharges. Based on that leakage, this is very important. So, only this slide will cover the entire security. Please try to understand. If you have any doubts, please put the questions. So if you have, so while doing the AI accelerators, if you wanted to do matrix multiplications, a lot of matrix multiplications, you need to put a lot of execution units. Like, instead of having one road, if you have like multi-lane, 6 or 10 lanes, you can put lot of buses, right? Lot of buses can go there and then come back within like certain time. Now too many buses you can send them. Otherwise, if there are only 2 lanes, you will send 2 buses. It will take like 1 hour to come back. Again 2 buses. Take lot of time. So similarly, you have A accelerators means once it detects it is a application, then it will trigger the CPU as a driver. It gives controls to the TPUs or GPUs. TPUs are tensor processing units from Google, and GPUs are a generic name, graphics processing unit. So they will be having a lot of data running through the channels. When the data is happening, there will be some power leakage. There is a lot of data. Based on that power leakage, attackers can steal the data, can estimate what kind of data it is being processed. That level of attacking is happening right now. So hardware trojans. You might have seen, you might have heard software trojan, right? Trojan virus in our laptop. So similarly, we do have the hardware trojans. Yes, I will be talking more on my coming slide. Hardware trojans. So while doing the fabrication or while doing the design itself, if they are putting something inside design or at the fabrication level or at the third-party application, third-party component, you know, right? So the design, fabrication, and all everything will not come from single company. It will come from multiple companies and multiple geographies. Multiple countries contribute. For that matter, Taiwan and Korea, they have most of the fabrication happens there. Most of the manufacturing. So while designing the code on RTL code, they can put one small malicious hardware. And then what is the malicious hardware? What it does, we'll see more in the next slide. Yes? I'll tell you. So there is one very clear-cut example which Bloomberg published, and it was countermeasured by China, but I'll be talking about it. So there are these are the vulnerables. They've been there. See, the beauty of the VLSI is once you master it, it will be there. The only thing is first you need to master it. Okay, so these been there, but from a different angle. So side channel attacks can happen from different caches or from different purposes. Hardware trojans. Adversarial attacks and AI models will be. I have a very good forum on these hardware trojans. So insertion points, right, while doing the design, doing the fabrication, so activation. So while once though they are designing, they are putting some malicious hardware, while the system, once we get out of the system, right, there will be a testing again. Why the testing is not catching such bugs? Because they will do something like it will get triggered by rare signals. If you run the laptop at some optimal temperature, like 30 degrees or 35 degrees, if you run the operator, if you put the laptop in that particular temperature, then it will trigger a certain signal. Similarly, voltage. If you give more volts to the system, then it will trigger. So this is the main important point, how the attackers can do. For example, we did the drone strikes on Pakistan terrorist attacks. Right? I'm taking that example because it became viral, right? That is the reason why I wanted to connect the real life examples with the technology. So if the drone is not indigenous, indigenous means it is not built within India, we cannot trust. Why? Because the drone can have a malicious white code in it. For example, if it is coming from China, since it is our enemy, I am just taking that as an example. So if that drone is coming from China, and they would have inserted some malicious code within the fabrication, it came. We inserted all the natural language. The moment we insert, it will give the information to Pakistan. Then they will directly counter attack wherever these are being launched. Then it will be more harm to us. Or just after launching, they can redirect that to fall into our region. That can also possible. So these are very important. So real risk, like I was taking the military example, consumer devices. This is the one. 2018, Bloomberg reported Chinese spies, they have implanted tiny chips in the super micro motherboards just to steal US sensitive information. But that counter-argumented by the Chinese. But such things are happening. Detection and countermeasures. How can we detect such things? We have to do rigorous testing. Once we have the hardware, we have to do rigorous testing. Right? We should go for the extreme ends, high temperature, low temperature, whatnot. So, doing the DDFS and having, why it matters, because the supply chain, as I was telling, like the chips won't come from single company, or it won't be coming from single country. It won't be coming from single country. It will be coming from across the globe. And the funny part here is we can't even patch it. If it is a software issue, there will be a firmware. So we can patch, we can send the patch through our software, through the OS update. Through the OS update, we can add a patch and then we can send it. So that the issue will get sorted. But in terms of hardware versions, we can't even do that. So evasion attacks. What is evasion attacks? This is more related to the AAML, evasion attacks. The goal is how do you train? Once you have the AA model, right? You need to train the model. How do you train the model? We were talking about the GPT-1, right? How much time it took for training one model? 1 month, 1 to 2 months, and all of this stuff. What do they do during the training? I will do like, if I give this word, then it should give this much. This should be the output. So then we keep tagging. This word is nothing but a key, and whatever comes out is a output, right? Suppose the capacity needs to be trained. The intruders can pick the A model. Okay, they can pick the A model to misguide you. For example, there is written recent advancements, right? If I scratch something there, what it becomes? Beyond advancements. The meaning of it itself is it differs a lot, right? So such things can happen. So the real-time example is self-driving cars. They are very much clear. So they've been deployed in many parts of the globe. They are doing. So why? So there will be like a lot of signboards, right? If you wanted to sue one of the companies, the company or the owner, he might be sitting in the owner might be sitting on the back seat, and the car will be keep going on the road. There will be a signboard. Please speed down. There is a one curve, one sharp curve. It won't. If we make that as something, it cannot be changed. Then what happens? Car will go very fast. Then there will be a massive accident. and we might, the owner might lose his life. So real world examples like autonomous vehicles, like facial recognition, like the Google goggles. Goggles are the AI power. You know, a lot of these the kind of behavior they're talking about no more TV and no more other things. Going forward, the goggles will play a dominant role, like within the next 5 to 10 years. When you do, so you can see, watch the real time, you can watch a movie or anything in real time. It's just the lens. So with that lens, whenever it has the input of the eye, your eye. Now whenever you can open your phone or any of these things through the eye contact, through the facial. These information gets stored in the goggles. So if they attackers able to steal this information, they were able to get all of those passwords, right? So they can do your bank information, everything, what not. If you are a higher official in any government or defense, they can steal anything. Like counter pages. How can we counter these things? Like adversarial training. Just like Trojan hardware, you can do the regress training here. Going to all ends and input sanitization. Like input sanitization, like if it is reorient, it cannot understand that's not there in the dictionary. So it can block that. But what is the implication of that? It can drop in legitimate inputs. It might be legitimate, it might be added, but the A does not know that. Right? Randomizes something. We can add some noise to the inputs while encoding. But this will reduce our accuracy and performance. It is a lot of things, right? We will take the image tag and then add some noise, some encryption, like tag, TTT. That is some noise. But adding that will increase a lot of computations. So we are going to lose the accuracy and performance. So why does it matter? As I was talking about, one is the life, we are using lives, and it can pull the medical aid. For example, we prescribe some other thing, some other medication, which is totally wrong. So these are the various CPU security bugs, meltdown, spectra. So all of these are side channel bugs when you come to the side channel. So these are the timeline bugs. We'll talk about what is the revenue impact of this particular generated bug, which was very recent on the timeline of 2021 from AMD. This is also known as sideline bugs. The direct cost, once you detect the bug, right, what will happen? Just like our build leader, there will be always one super power teams. They will be always on high alert, 24 hours. Whenever something comes, they will go on. They will be at the forefront. Similarly, even at companies, there will be certain teams. Whatever they see some bug right from outside, they will jump on it. They have to prepare a patch. If they software, most people will be software. They will prepare a patch. The patch cost will be very high because they are that sharp. We have to invest more on these particular team to retain those people. And the performance penalties. Once you send the patch, right? For example, you might have rolled out one very latest feature in that particular CPU, but that feature is having some issue. So there will be certain ways to disable that feature completely through software patch. But if you are disabling, you are going to lose a lot of performance. But you need compromise. That is the performance penalty we do. Okay. So because of this, Because of this, the competitor might take advantage. And indirect cost, like there will be a lot of indirect cost. Your company's stock price might go down, and it can be recoverable or it cannot be within the stipulated time. And moreover, it will be a big loss to the server companies. For example, we have three things, right? Mainly the major server. Now the world is powered with lot of server. So everybody is connected one or the other way with the server. Amazon AWS, Google Cloud, and Microsoft Cloud. So since you are reducing the performance, the same CPU or GPU will be going here. That will incur 10 to 15% performance down. Since it is having low performance, they will run very slow. So if you are running instead of one application in 1 hour, it will take like 5 to 6 hours. What will happen? They are going to incur more of the power charges. So you might think it's only the power, right? No. And running too many servers, it will incur lot more. There will be a humongous power loss. Reputation damage, of course. There will be again mitigation cost. So this is only the temporary one. Next time they have to take this bug, that particular feature, and they have to modify such a way. They have to do the security, how it cannot be breached by attackers, all of this. So it costed like around $2,000 million, that is approximately 1,600 crores. But to the company, it is when we compare with the processor dominant Intel, when it started with the meltdown and Spectra bugs, right? They were like 1.6 lakh crores. The impact was that. You can't even imagine. Do you imagine how much is our AP budget per year? It's like around 2.5 lakh crores, right? It was 1.6 lakh crores. But being a leader in the processor, Intel survived that attack. Obviously, followed by other companies. Both the other companies got impacted, but since Intel was having like more than 90% of the market share, it impacted a lot. Okay, now we talked about the security. What is the reliability challenges? Okay. Okay, so what? There will be a ABS. ABS is nothing but 512 bit. So most of the say core internal, there will be like somewhat. I'll be going a little bit deep. We will be using some registers. So we will do the move A comma B, right? While fetching the data from end load, we have to keep the data in somewhere in the CPU. Those are called the register files. You will understand that in the computer architecture, microprocessor. So these are the PR, physical register files. We will store the data there. Those lengths will be like 8, 16, 32 bit, all of these. But though outside we will use different variants, but physically all of that in the same register. We will be just reusing the same, right? So if my application is taking only the previous user might have used one banking application. He might have logged into his bank and then logged out. That information will be in that is the sophisticated application, and it might be using the full PRF, 512 bit PRF, and then we have one zero upper instruction in the AMD microarchitecture. When they run up that application, it is supposed to clear all the upper bits. Okay, all the upper bits it has to clear, but instead the CPU failed to clear the data in the upper bits. As a result of that, the attackers now can read the upper bits and get the passwords. Then they can steal the data, right? So because of that, it faced. So this is one of the side channel attacks. You are asking about that. So let's see about the. So we are almost in fault tolerance. These are the soft errors. For example, because of the radiation, you might have bought your laptop like Japan 4 to 5 years back. Okay, the hardware might be melted like anything, and then instead of reading, so computer will read only zeros and ones. It won't read the human language, right? So instead of reading 1, it reads 0 somewhere or other. Everything will happen. That is a software. Even the aging effects, radiation. If you instead of operating the laptop, so while buying a laptop or phone, they might have listed at these temperatures you can use the laptop. If you use the laptop under very hot climate, under 50 degrees Celsius or more than that, then it won't operate. It will stuck. So most of the computers, wherever it is, they will be equipped with ACs that under controlled temperatures it will be maintained. This is the reason. Okay, software and process variations. For example, during the manufacturing, they might have reduced some imperfections. What is the? How do we manufacture chips? Using silica, right? Silica. So silica and then some metal items. If they are not fine clean, that is the reason when you see all the labs, for example, Intel fabrication process, or for that matter, any other fabrication process, TSMC, or Samsung labs, right? They'll be covering entire your body. None of the impurities will be entered into them. They will make sure everything is clean and tidy. Why is that? Because of these process regulations. If some or the other impurities gets injected there, it will vary the performance. So the thermal issues we were discussing. So what are the mitigation strategies? Like we talked about all of these. The real-time industry examples, how they are dealing with the security and the reliability issues. Intel being a leader in the processor domain, hardware enforced security. FUSA, they call is functional safety. They are using error correcting boards. You might have heard about error correcting boards. They will send something. They will check whether the data which we send is properly received or not using error correcting boards. And HGX, security guarded extensions. They will isolate. For example, there are two people using the same servers. So two people subscribe to the AWS server. You both will be given different machines, different end users, but you both will be using the same server in the end. So what will happen? The processing. One person will give some information. It goes into the one of the cache. The second person, he will type something. If the other person is doing some bank information, some password and address, that will go and sit in the cache. The second person doing something, maybe he is a potential hacker. So what will happen? Even his data goes and sits in the cache. Now, if he reads the data from the cache, there will be like speculative execution. What is this speculative execution? I think I'm going very deep into the program. I think it will be too much for you. So I wanted to. You just think we are having security at each and every layer inside the processor as well. That is the idea. So like triple modular redundancy. What is that? Instead of having, this will be used for real-time applications mainly. Instead of executing on one area, we will keep like 3 areas. We will execute on 3 areas the same instruction, and we will check the output. If the output is same, then we will process that. If the output is not same, we will execute again. So it matters a lot in the real-time applications. When you are operating aeroplane, or when you are operating through drones, or when you are on the satellite communications, this matters a lot. So similarly, NVIDIA also does this. These are, as I was talking about, I use these applications day in and day out. Though, but grammarly talk about it. These are the text generation platforms. This is the PPT generation Gamma notebook LLM. It gives very beautiful things. If you load it, time permits, I can give you some small demo, but I think we are out of time. That is okay. You can try this notebook LLM. It's free of cost, but it's very powerful. So when you load something, right, a very big video, you can just give YouTube URL. If you insert the YouTube URL, you can ask the questions. You insert the YouTube URL, and it will give you what is inside that YouTube URL in a summary form. And then it will create some podcast kind of. You know podcast, right, where 2 people will be talking about the topic. So one will be asking the questions, interesting questions, the other will be replying to the questions. But the original video will be only the one-sided communication. But it will generate then podcast with 2 people talking about the topic. Very beautiful. You should try it out. But all of these are AI related. So there is a very big caution here. Don't feed your sensitive information. It is going to fail the entire AI. With that, I think I would like to wrap up this couple of things. Hope I gave some interesting info here. I wish you all the best. Thank you.